Good morning, YouTube. Wanted to show you my motion sensor light. This is the version with the warm white LEDs. So these are, I think they call these copper wire LED strings, and what they have is a pair of enameled copper wires, and then they have little LED beads soldered between the wires. And then I've got my motion sensor here on a little bit longer cable, and with the warm white I've also added a 4 battery box, so that's nickel metal hydride. I've got 4 Eneloop AA cells in there. These have been running for 4 months. I have not opened the box up. Built the circuitry separate here. I have my power coming in here, the red and black wires. I put a small electrolytic capacitor there for a little filtering. There's your 2N3904 switching transistor. I think I put a 2200 resistor between the motion sensor output and the base of the transistor, and then I have a 150 ohm going to the LED string. And with this thing I set up a 9-pin right angle header. I've got 3 pins for the sensor over here, 3 pins for LED here. Of course you only need 2 of those 3, but I just picked up some of these 3-pin, I think these are ESC or servo connectors, just to get the connector and the wires. And then I left room for a second set of 3 pins to drive perhaps a second string of LEDs if I decided I wanted to add 2. So these are my warm white motion sensor lights, and you can see it doesn't turn on, but if I turn off the lights in the room, now if I go close to the sensor, I get light. If I have the lights on in the room, the motion sensor doesn't turn on, and if the lights are off, it does turn on. So that's exactly what I want. Okay, let's look at some of the power consumption figures that I worked out. So going by the data sheet, the PM8 motion sensor, which is this guy right here, uses about 50 microamps on standby. So if you work that out, that's about 8.4 milliamp hours per week. Now the 10-foot 3-meter string of warm white LEDs on 4.8 volts, and I'm using the 150 ohm series resistor. When they're on, I measure 2.29 volts across that resistor, which works out to 15.3 milliamps, or that would be 15.3 milliamp hours per hour of on time, running 30-second timer on the motion sensor. That would equal 120 triggers. So, and if you estimate about 24 triggerings of the light per day, that would work out to about 6 hours of darkness and 4 triggers per hour. So that's a pretty reasonable number, I think. With taking 15 milliamp hours and divide by 5, you get roughly 3 milliamp hours per day, or 21 milliamp hours for a week. So if you add this 8.4 and 21, you come out with approximately 30 milliamp hours per week. Now the battery capacity on the Eneloop AA's that I'm using is 1900 milliamp hours, so that works out to 63 weeks, which is well over a year. Now I've been running this light for about 4 months and it's still working. I haven't charged the batteries. Of course, this number here is ignoring self-discharge of the batteries. So even if that works out to about the same amount as I'm using, it would still run about 6 months. I'm pretty happy with that. I've gone with the nickel metal hydride here, as I don't have to do any battery protection. I can just run this whole motion sensor light until the LEDs don't light anymore, which would put it down about 3 volts in the batteries, which would be about 3/4 volt per cell, which is pretty much a dead nickel metal hydride. So once the LEDs turn off and don't turn on again, that's my clue to charge the batteries again. The other option I could do is replace these nickel metal hydrides with, say, a protected 18650 cell. That would be maybe 2500 milliamp hours, so it would run quite a bit longer, and with the built-in protection that would also work here, because that battery would shut off around 3 volts. Anyway, I just thought I'd show you my updated warm white motion activated LED step light, and this has been running for 4 months. It works perfectly well. Maybe I'll give you a shot of it when I finally get it installed in its final position. Until then, you can check out my channel, subscribe for updates, and if you enjoyed this video, give it a thumbs up, share it with your friends, and as always, thanks for watching. See ya!